Okay, in this lesson we are going to talk about combinations, and then in class we'll do some additional work with the combinations and then tie them in with permutations and how are these two things different, which leads to our central question. How can we tell the difference between a permutation and a combination? So how are they different? How are they the same? Think about all of those things. Combinations are a selection of objects in which order is not important. If you recall with the permutations, it did make a difference the order in which you arranged the objects. In this case, it doesn't matter. I usually like to think of it as a combination pizza. That's how I used to be able to remember to tell the difference between the two. Once you get your base, okay, so you've got your sauce and your cheese, that's the base, then the order in which all the other toppings go on top of the pizza does not matter. The pizza is still going to have all the same toppings on all over it. So a combination pizza is one way to think about a combination and order not making a difference. Doesn't matter the order in which things are done in. So some key words to help with this would be like group or committee. Those are some common ones. There's lots of others. So here's an example where we are just going to systematically list all the possible outcomes, selecting 2 letters out of the 5. So we start grouping them together. So A, B, A, C, A, D, A, E. Okay, so we've grouped the letters together. Now we're going to work with the B and group the B with all the other letters, except we don't have to do the B and the A because that's the same as AB. It's the same group of 2 letters. So that's counted as the same thing. It's already there. So we're going to go with BC, BD, and BE. Same thing with the C and the B. That's the same as BC. Okay, CB and BC are the same thing. The order does not matter, so it's the same group. So we'll start with C, and we'll do CD and CE. And then you have DE. So then we can count to see how many combinations there are. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 combinations of selecting 2 letters from the 5. The next thing we're going to look at is our formula for combinations. So this is how it's usually read. N choose R. So N is your total number of objects. R is how many of those objects you are selecting. And then the formula is n factorial on top, n minus r factorial on bottom, times this extra r factorial on bottom. That extra r factorial is what eliminates all the repeats. So if you don't have the r factorial, that's the same as a permutation formula. So with a combination, we just add the r factorial in there, and that cancels out all the repeats. So if we use this formula on the previous problem, there were 5 letters that we had in our list. We were choosing 2 of them. So 5 choose 2. So that'd be 5 factorial on top, 5 minus 2 factorial on bottom, times 2 factorial. So then simplify a little bit. 5 factorial, divide 5 minus 2 is 3 factorial, and 2 factorial. So let's write it all out. 5 factorial is 5 times 4 times 3 times 2 times 1. Remember, the factorial means you start with that number and you multiply all the numbers below it until you get to the 1. 3 factorial, start at the 3 times 2 times 1, multiply everything below it, times 2 factorial, which is 2 times 1. So then you'll notice that we have the 3 on top and 3 on bottom, so those equal 1. 3 goes into 3 one time, 2 into 2 once, 1 and 1. Then you can simplify other ways. 2 goes into the 4 twice, so you have to be careful with that. And then don't forget to multiply those 2 numbers together. So I have 2 times 5. So the answer is 10, which is the same as what we got when we listed them and counted. So combinations and permutations are just ways of counting how many possible outcomes there could be. It's very useful when the numbers start getting really big. So next example. So we're choosing 2 elective classes out of a list of 6. So we want to know how many combinations of electives are possible. So the first question you have to answer anytime you're looking at any of these problems with combinations and permutations is, does the order matter? Does it make a difference? Is there order to what I'm selecting? In this particular case, if you think of elective classes, if you have to pick two, it doesn't really matter the order in which you've picked them as long as you get the two electives that you want. In this case, order does not matter. So no, the order does not matter because it doesn't matter the order you select your electives as long as you get the electives you want. So when you are explaining whether or not the order matters, make sure that you are giving context to the problems. What I mean by context is the fact that you're talking about the electives that you're choosing, how many of them you're choosing, and then adding in any extra piece that explains why that does not matter the order in which they are selected in. So you have to include some of that context, not just it doesn't matter. You've got to explain why. So then we're going to do our solution. So we have 6 total electives to choose from. We are choosing 2 of them. So always write your notation. Remember, the first number is always the total number of items you are selecting from, and then the second number is how many you're actually going to select. So then when we set up our formula, it's the first number on top, so 6 factorial on top. Then you subtract the 2 numbers on bottom, so 6 minus 2 factorial on bottom. Then it's just the last number factorial on bottom. So you go first, both, last. Let's simplify first. 6 factorial, 6 minus 2 is 4 factorial, and then 2 factorial. Don't forget your factorials. The factorials are very important. They have to be in the problem, because the 6 by itself does not mean the same thing as 6 factorial. So make sure you have your factorials in there. So 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. 4 factorial means 4 times 3 times 2 times 1 times 2 factorial, which is 2 times 1. You can see that on the bottom we have a 4, 3, 2, 1. On the top we have a 4, 3, 2, 1. So that's all going to equal 1 when you divide by the same thing. 2 goes into 6 3 times, and then you just have to remember to multiply the numbers that are left, because on the bottom all I have is a 1 left. On the top, 3 times 5. So the answer is 15. So there are 15 ways you can select 2 elective classes out of a list of 6. So the next example. Your teacher randomly chooses 2 out of 18 students to give an impromptu debate on freedom of the press in high school newspapers. How many ways can 2 students be selected? So again, you have to ask yourself, does the order matter in which these 2 students are selected? In this case, no. Whether you get selected first or second, you still have to give the debate. So it doesn't matter the order in which you're selected, you're still giving a debate. So we have 18 students in the class. The teacher is choosing 2 students to give the debate. So when we set up our formula, so 18 factorial on top, divide by 18 minus 2 factorial on bottom, times 2 factorial. So then that's 18 factorial, 16 factorial, 2 factorial. As I did with the permutations, we're going to take a look at this and use a shortcut. So if you notice on the bottom, we have the 16 factorial. So when I do the 18 on top, I'll start 18 times 17 times 16 factorial. So the factorial just means I have the 16 multiplied with everything below it, 16, 15, 14, all the way to 1. And then on the bottom, we have a 16 factorial times the 2 factorial, which is 2 times 1. So notice on the bottom, we have a 16 factorial. On the top, we have a 16 factorial. So when you divide, that equals 1. Then you could simplify with the 2. 2 goes into 18 9 times, and then you just have to remember to multiply. 9 times 17. So our answer is going to be 153. So there's 153 ways that 2 students could be selected out of 18 to give the impromptu debate. Okay, to take that one step further, now we're going to look at the probability. Okay, the probability that your teacher chooses you and your best friend. Combinations and permutations are just counting methods. Methods to find total number of possible outcomes. So when we're looking for a probability, the bottom number, it's always a fraction, the bottom number is the total number of ways that selecting 2 students can happen. We already did that calculation right there. Okay, so it can happen 153 different ways that you could pick 2 students to give the impromptu debate. How many ways can you and your best friend be selected? Okay. That is only one. Whether you were selected first or your best friend second, or the other way around, your best friend first and you second, doesn't matter. It's still you and your best friend, and there's only one group with you and your best friend in it. So that is the probability, 1 out of 153, that you and your best friend could be selected for this impromptu debate. Don't forget, we are at the end of our lesson. On the left column, you want to include any study questions for yourself as part of your notes. So go through, reread the notes, look at what you wrote, see if you can come up with some study questions. Also, at the very, very end, after you've come up with those study questions, periodically I mentioned permutations and some of the similarities and differences with permutations and combinations. So see if you can describe some of that at the end of your notes. And then we will talk about both of those and do a lot of practice work next class.